on the review packet from today. The first one gives you two triangles, and it gives you some basic information on there. It doesn't give you enough information to say that the triangles are actually congruent. Now, on here, these two arrows mean that those lines are parallel. If you see parallel lines, most likely you have alternate interior angles. So on here, this line here, BD, is acting as a transversal. So alternate interior angles on BD would be these two angles. Now, notice, I'm not marking them as right angles, I just mark them as congruent. We don't actually have enough information to mark them as right. Yes, they look like right angles, they probably are right angles, but you can't assume anything. Now, those two are congruent. We also know that the segment that's shared by both triangles is congruent to itself. So, reflexive property, BD is congruent to BD. Now, what the question is actually asking is, what other information do we need to know in order to say that these triangles are congruent? Well, currently, we have two pieces of information. You need three. So we only need one more piece. But there's more than one way that we could prove that triangles are congruent. So, on the first one, it says angle ABD is congruent to angle CDB. ABD, CDB. Already have it. We don't need that as more information. So we can cross that one off. Again, we can already figure that out based on what's given. Angle C and angle A are congruent. That'd be this angle and this angle. Well, I'm going to go ahead and use a pencil because I don't want to leave it on here permanently. But if I have this angle and this angle, those two being congruent, now I have an angle, and a side in each one. Two angles and a non-coded side, that's AAS. So this would work because I would be able to say by AAS. Now, it doesn't ask you to do that part, but again, I'm just going to write it down there just so you understand. That's what would allow us to say that they are congruent. Now, let's go ahead and erase that part because there's more. Segment AD. This segment and this segment. So AD and CB. Well, if I had this piece, I'd have a side, an angle, and a side. A side, an angle, and a side. But this would be in the order SSA, because that angle's not included. It's not between them. Does SSA work? No. SSA doesn't work. So this one doesn't work, because it's SSA. And you can't say it's HL, because do we know that this is a right angle? No. So there's not enough information to say that's a right angle, so we still can't use it. So that one's out. BC and CD. Well, BC and CD, those two are in the same triangle. Does that help us at all? No. So we need congruent parts between the two triangles. So the last one, AB is congruent to CD. Now we have a side, an angle, and another side. So by SAS, that's one that works. So the last one is also acceptable. All right? So those would be our two answers. Yes? Are you talking about this bottom one? So, again, on here, guys, listen. We have two sides and an angle. Now, remember, they can be congruent through many different types of transformations. Our last section was all about transformations, right? So again, it could be reflected, it could be rotated. Again, yes, they have to be in corresponding positions, but those corresponding positions you have to think about in terms of reflections and rotations as well. It doesn't have to be facing the same direction in order for it to be a corresponding position. Again, so on here, we have two sides and include angle. We have the same two sides and the include angle are the same. So this is going to work. If you thought of this as a rotation and took this and rotated it around to this one, it would lay exactly on top of each other. It would map onto the other one. So they are congruent. All right. For number 2, we have triangle ABC and triangle DEF have all these different things that are incongruent. Which criteria is it? Well, yes, they give me this nice congruency statement, but it's really hard to tell without drawing this one out. This is where you really need to draw it to see. So draw two triangles. Don't try and trick yourself. Draw them exactly the same. in the same direction and everything. So you can just go around and label the different parts. So one triangle is A, B, C. The other one is D, E, F. Notice I label them in the same order that they appeared in that congruency statement. Now, A and D are congruent. A, B, and D, E are congruent. A, C, and F, D are congruent. Now, looking at the diagram, it's easy to see we have two sides and an included angle. So this would be SAS. Number 3. Suppose triangle ABC is congruent to triangle LMN. And the side lengths of triangle ABC are shown in the table. What is the longest side of triangle LMN? What does that say?
Number 3.
Okay, so on here, these are the lengths of this triangle. All this is really asking you to recognize is that they go in corresponding order in this statement. So, what's the longest side of the first triangle? First of all, BC. So, BC corresponds to MN. That's all they're asking. That's the answer. You can draw a picture. Again, you don't have to draw a picture on this one, though, because, again, based on that congruency statement, they're in corresponding order. So if you can identify which one's the longest for the first triangle, then you should be able to identify what the long side of the second triangle is. You could even say what MN is if you wanted to. We can say that MN is equal to 8.4. Because, again, it's the same. All right. On number 4. Now, I saw Miss Oswalt, she gave you another piece of information, right?
What?
On number 4, wasn't that the one she wrote something in on?
Yeah.
All right. So, we could solve this a couple different ways based on the given information. Because, given the median, and if you have this right angle symbol in the diagram that's shown there, that's actually enough information to say it is a perpendicular bisector. So you could go off of that information that Ms. Oswalt gave you, and that would be enough information. Now, there is more than one way to solve this. So I'm going to do it based off of the information that's currently here, but I will tell you how it can change if you wanted to use the perpendicular bisector as well. So based on this information, we said that this is an isosceles triangle. So triangle FGH is isosceles with base GH. What does that actually tell me? It tells me these two are congruent. So GF is congruent to HF. Now, how did I know these two things? There's not one on the test that's completely blank. Yeah, there's not any that's completely blank. No, because technically we haven't talked about, again, you guys should know what isosceles triangles are, but we haven't mentioned them yet. What was the question there? Yes, all right, good. So this one's given, and this is definition of isosceles triangle. Now, the other thing that was given is that this is a median. If I only use that information, and that's given, so, guys, in a couple sections, we're going to go over medians. But I'll tell you right now, a median is a segment that connects a vertex to the opposite midpoint. So all this is telling us is where the midpoint is. So since this is a midpoint, we know these two are congruent based on our definition of a median. So GE and HE. Yes. Because again, you're going to be you're going to know that's a midpoint from that information. So therefore, if you wanted to get really technical, you could probably string it out into an extra step. So like, if you really wanted to, you could probably go ahead and say, instead of going straight to this definition of median, you could probably use an extra step in there and say, this is the median, and have that as a step before it, followed by E is the midpoint of EH because the definition of median, and then those two are congruent because the definition of midpoint, if you wanted to get really technical. All right. But now, we have two congruent parts. We need a third congruent part. Well, this line in the middle is congruent to itself. Therefore, FE is congruent to FE through reflexive. So the two triangles are congruent. Gentlemen, and this would be SSS based on this idea because you have all three congruent sides. Now, Ms. Oswald said that instead of saying median, you could say perpendicular bisector, right? Is that what she said? Segment bisector? Okay, so if she said segment bisector, it's probably going to be the exact same as what I have here. However, if you used, if you used the idea of the angle at all that was marked in here, that could change your answer. Now, it depends on which piece you left out, what you could do as your final answer. Because if you use that angle and you used the two legs of each of those right triangles, then you would have said by SAS. But if you left out one of the legs and used the hypotenuse, then you've had to use HL. So again, it depends on what piece you left out if you chose to use the right angle. Yes. Say again? The side, you said? So, I'm saying the sides are what we're labeling here with the congruency marks. Right? So, SSS, because we have three segments, the segments are the sides of that triangle. GFE, right here? So, that's saying triangle. Because again, it's saying the entire triangle is congruent to the entire other triangle. That's just talking about the entire triangle in general now. So again, you can have different shapes. Shh, guys. Different figures can be congruent. Again, we've had angles are congruent. We've had sides, the segments are congruent. You can have entire figures. So now we're talking about the entire figure of the triangle is congruent. It's the exact same figure overall. All right. All right. On number 5. You have, what are the missing parts of the flowchart proof? So, on here, you have 3 things missing. First off, this tells you that you have the definition of midpoint based on this statement. So, what do you know about midpoint? Midpoint bisects into 2 congruent segments. So, BD is being split into 2 congruent segments. BE is congruent to DE. Then on the bottom, you have angle BEA congruent to angle DEC. Those 2 angles are vertical. So vertical angle theorem. For C. All right. Well, we have 3 parts here. Let's go ahead and label this one on the triangle to help us figure it out, though. AE and EC. We have 2 sides and an include angle. So 2 sides and an include angle. The angle is between the 2 sides. So SAS. So again, that's the entire front. Let's see. We're going to get a new sheet for the back. So now, this one again, for the paragraph proof, again, I wouldn't make you guys write an entire paragraph proof from scratch on a test. Right? You would either have to probably fill in a couple blanks. Right? If you're given something like this on the FSA, you could have a paragraph proof as well. Again, they'd probably have something like a drag and drop, or maybe a fill in the blank, or a drop down menu type thing. Again, it could be a lot of different things. But again, essentially for a paragraph proof, it's the same thing as any of our other proofs. You're just taking the statement and reason that you were writing before and writing it as one sentence for each one of those statements and reasons. So on here, we are given some information. Now, if you want to list more information in one sentence, that's fine too. All right? But you're given a few different things. First thing that I see labeled on here is that we have right angles. So we could say that triangle H, J, K, and triangle, I'm going to list them in the same order for future reference, G, F, K, are right triangles. Now, that's given information. If you want to write it's given information in a sentence, you can write given information. You don't really have to provide a reason for the given information because it's given to us. Now, I could go on and say that we have a right angle. All right, because we have right triangles. So we could say, if you want to say these are right angles first, that's fine. Or if you just want to go ahead and say that these are congruent, I'm fine with that for a paragraph proof. So angle GFK. Thank you. Thank you. Angle J is congruent to angle F. Oh, sorry, I started going cursive there. Because all right angles are congruent. Huh?
Angle B?
Angle J.
That looks like a B.
J. Listen to me and you'll hear it. Alright. Now that we have those two taken care of, we can also say that these two angles coming off of K are congruent because of their vertical angles. So, angle HKJ is congruent to angle GKF because of vertical angle theorem. And then we can say that JK and FK are congruent because of definition of midpoint. Therefore, a triangle HJK is congruent to triangle GFK because of angle side angle congruency criteria. Alright? Nah. No. Again, it's not. You're not going to have to do a full paragraph proof. I'm not ever going to make you do a full paragraph proof all written out like that. But again, what you could see is part of a paragraph proof with blanks for reasons. That's reasonable to see on a test or a quiz or something. All right. But again, that's our paragraph proof. Now that we've said that they are actually congruent, we can say that this side would also be the same as this piece. So to answer the second question, is the lake long enough for the team to use as the regatta? Well, we needed it to be 1,500 meters. It's less than 1,500 meters, so no. It's not long enough. Vertical angle theorem? I said JK and FK are congruent because of definition of midpoint. Now, I didn't have a lot of room there to write. I abbreviated as much as I could to get this to fit in. I may have even skipped 1 or 2 steps to get this to fit in, because if I wanted to do this really accurate, it'd be much longer than this.
If we wrote less than that, but we still got to the point.
Again, if it was a true paragraph proof, we should actually include more information than what I just did.
Yeah, but
I kind of shorthanded this because there's not enough space.
Shorthanded it, would it still be fine? If we got to the point.
If I was actually testing on paragraph proofs, no.
Yeah, but I know, but on here.
On here, that's fine.
Yeah, okay.
All right. On number 7. Now, 7 is the idea that we've mentioned in this section, but it's not something that we're going to test you on in this section, because we'll see a lot more in the next chapter. So it tells us that these two triangles are congruent. It tells us that R is a right angle and B is 35. What's the measure of Q? Well, B is congruent to S based on that statement. So we have R and S, essentially. We know R is 90 and B is 35, so S would also be 35. If we wanted Q, we just have to subtract those two measurements from 180. So 180 minus 35 minus 90, and that would be 55 degrees, and that would be angle Q. Angle T is the same as angle Q, so that's also 55. Angle U is the same as angle R, so that would be 90. Again, not on this test, but you should know how to do it. On 8, are the triangles congruent? If so, which theorem allows you to prove they are congruent? We have 3 angles. Is AAA acceptable reason for congruency? No. So no.
Yeah, I remember, like, you can have, like, an angle.
Or, I should say, not enough info, because only angles are labeled. AAA is not a congruency criteria.
Why would we put not enough information instead of non-congruent?
Now, the reason why you should say that we do not have enough information to say they're congruent over the fact that they're congruent or not is because we don't know if they are congruent. Again, there is most likely any problem where it's asking you to prove whether or not the triangles are congruent. The triangles are going to look congruent. They may even be congruent. But whether we have enough proof is a different thing. So just because we say that we don't have enough proof doesn't mean that they're not congruent. These two triangles, they look congruent. They may in fact be congruent, but we don't have enough information to say that they are.
Why can't it be AAA, though? You said earlier something about AAA.
AAA doesn't work.
It doesn't always work.
AAA, we would have to have a side, because you can have two triangles with all the same angle measures, but be two completely different sizes. When we get into similar figures later on this year, AA, similarity, is going to prove that two triangles are similar, meaning that all the sides share the same ratio. Now, it is possible that they share the same ratio of 1 to 1, and then they would be congruent. But we don't know what that ratio is, therefore we have no clue. So again, tying in something from later in the year. All right. 9. What theorem allows us to prove triangle VWX is congruent to triangle JKI? What values of Y and Z make them congruent? So now, the figure is marked with congruency marks so that you can say which one it is. Which one of our theorems or criteria would this be? HL. We have a right triangle with a hypotenuse and a leg. Now, for this part, if these two are congruent, we should be able to set them equal. So 3z equals z plus 12. Subtract z, you get 2z. Divide by 2, z is 6. For y, these two hypoteni should be congruent. Subtract, you get 7y equals 42. Divide by 7 and you get 6. Which one? Down here? 8y equals y plus 42. I just set these two equal, the two hypotenuse. These are hypotenuse. Yeah. They're marked as congruent, therefore their measures must be equal. So we set them equal, and then we solved. We subtracted the y, and then divided by 7, and got 6. On this one, same thing. Set those two equal, subtracted the z, divided by 2, and you also get 6. Alright, the last one. Sorry. Alright. Now, for number 10, guys,
I apologize.
yeah, a little loud, quiet. So, on 10, given that EF is parallel to GH, so they're telling us they're parallel. They're not currently marked as parallel on the figure. So you should go ahead and mark these as parallel. What was currently marked on the figure is the fact that they're also congruent. So you have two pieces of information given to you.
Oh, wait. Oh, okay. I was wondering where the next given was.
Yeah, two pieces of given information. You have the fact that they're parallel. That's given.
You're an idiot.
Yeah, don't do that. I don't need the police here for no reason. Alright, anyway, on here, you have these two are marked as parallel, and they have a mark on them for congruent. That's the second given. So, EF is congruent to GH. They are congruent. Now, we know some other information here. Based on the parallel lines, again, anytime you see parallel, alternate interior angles would have to be congruent. So, these two would be alternate interior angles. So, angle, and there's more than one way you can write this, but angle HGE is congruent to angle FEG is of alternate interior angle theorem. Now, you also have a common side. So it has to be congruent to itself. GE is congruent to GE. That's reflexive property. Or if you want to be like Springboard, you can say congruence is reflexive. Now, once you say that, we have three congruent statements. Again, 3 is the magic number. The triangles are now congruent. So triangle HGE is congruent to triangle FEG. Now, the one thing you have to be careful of when you write those congruency statements, you got to make sure that they go in corresponding order. Finally, you can say the last piece is congruent to the other one because of CPCTC. Corresponding parts of congruent triangles are congruent. Again, you need to know that for the test. Alright, that's a whole review. Alright, if you have other questions, I'll go over them still. Let me stop this recording so I can post that.